Hi, hello, hi. Okay, today we shall be developing vector error correction model, and here are few steps involved in developing I'm sorry, there are few steps involved in developing VECM model. Okay, step number one, lag selection, right? That is step number one. Step number two, Johansen test of co-integration, and step number three is the VECM model, right? So there are three steps are there. Okay, and we have three variables in this model. Those are GDP, cons, and export, right? EX. So we have these three variables, and here our cons actually is the dependent variable, and GDP and EX are the independent variables. Okay, so the first step is the lag selection that that we shall do first, and then Johansen test of co-integration, and finally VECM model. Okay, so first our variables are here. You can see our variables cons, EX, and GDP. So data from 1960 until 1995 data are here, right? So this is a time series data. Okay, and first we check lag selection. That means how many lags should be used in the system in the in the system equation, right, that we shall develop now. Okay, lag selection. Okay, so what I do, we have three variables, right? So I go to statistics, right? I go to statistics, then I go to time series, then setup, that is declare data set to be time series data. So I do it, and here are the data. So I select this on observation, right, and I press OK. So you can see our data from 1960 to 1995. Okay, from here we can select number of lags to be used. Okay, then I go to statistics, then I go to multivariate time series, then I go to var or diagnostic test. So I take lag order selection statistics, right, that I select. Okay, and here I put our all variable cons, EX, and GDP, and suppose maximum lag I select 4 here, right? Maximum lag I select 4 here, and you see from here, so I press OK. So it is coming up gradually, lag selection criteria. It is coming up. Yes, she has come finally, and you can see the results actually. So this is the lag selection criteria. Okay, here are few criteria. Number one criteria is LR, then FPE, then AIC, HQIC, and SBIC. And here you see that the star is given. Star means actually that is selected by LR, right? So meaning that according to LR, 3 lakhs should be chosen, right? And then what about this criteria FPE? Here is also star is here, meaning that 3 lakhs should be chosen in our model. And AIC, so what is the guideline? Lower the value, better the model all the time. And here 17.32 is the highest and 2.18957 is the lowest. So meaning that the lower the value, better the model, and that is why star is here, because 2.18 is the lowest. Okay, then the HQIC criteria, also here lower the value, better the model. So here 2.64 is the lowest. That is why star is here. That means 3 lakhs should be chosen, right? Then SBIC is also the same criteria. Smaller the value, better the model. So here you can see star is here because 3.44 is the lowest, and here 1 lakh has been recommended. Okay, and here all criteria are good and efficient. So it is up to you which criteria result you will choose. That is up to you, right? Because all criteria are good and efficient. Okay, but what we see, LR is telling 3 lakh, FPE is also talking about 3 lakh to be chosen, and AIC also talking about 3 lakh, HQIC also talking about 3 lakh, meaning that 1, 2, 3, 4 criteria out of 5 criteria are telling to take 3 lakh, right? So better we take 3 lakh in our future model, right? Okay, and also we can check the things again in other way. I go to statistics, I go to multivariate. Okay, this time I check the VEC diagnostic test, that means vector error correction model, and lag ordered selection statistics. I select it, and here I put also maximum lag order as 4, right? So I press OK. And here you can see, actually you can see the same thing is telling. LR is telling the 3 lakh, FPE also telling 3 lakh, AIC is telling 3 lakh, HQIC is telling 3 lakh, but SBIC is telling about 1 lakh. Actually, both the outcome is same, right? You can see this outcome, right, and this outcome is same, no difference. You can see, you can check, right? Both are same. So actually this one is the VAR model, and this one actually VECM criteria, and both are telling the same thing, right? Giving the same result, right? So better we select lag 3 because 1, 2, 3, 4 criteria are asking us to take lag 3, right? Lag 3, right? This is the lag. Okay. So we shall be using lag 3 in Johansen test of cointegration and also in the VAR or vector error correction model, because all models are system equation model, right? And our lag selection criteria is also system equation model. So we can select lag 3 in all system equation model. Okay, so the lag selection is done. Optimum lag is 3. Okay. Okay, then our second step is what? Our second step is that is the first step. Second step is Johansen test of cointegration, right? That is the second steps are here. Okay, now the question is that how shall we do this test, right? Okay. Okay, but here there is a precondition of Johansen test of cointegration. What is the precondition? Preconditions is variables are non-stationary at level, but when I convert all the variables into first difference, right, then they will become stationary, right? Meaning that integrated of same order, right? Only then I can run the Johansen test of cointegration, right? Meaning that variables are non-stationary at level, meaning that the initial data should be non-stationary, but when I convert all the variables into first difference, then they will become stationary. And when this thing will happen, only then we can run the Johansen test of cointegration. Okay, now we check about our variable. Okay, okay, our first variable is cons, right? Okay, I check the cons first. I go to statistics, I go to time series, I go to graph, right? Then I go to autocorrelation and partial autocorrelation, right? And first I check our cons variable at level. So this one is at label data, initial data. So I select OK. So it is the result of correlogram. You can see from here, it is the Q statistics are here, right? The Q statistics and corresponding probability value, right? Okay, corresponding probability value. All are very small, right? All are very small. What is our null hypothesis? The null is variable is stationary. And what is alternative hypothesis? Variable is not stationary, right? So that is the alternative hypothesis. Okay, here you can see the p-value, all are less than 5%, right? You can see they are very small, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, meaning that our cons variable at level, they are non-stationary. Okay, now I check what happens after the first differencing of cons variable, right? Okay, I go to statistics as before. I go to time series, then I go to graph, then I go to, I do it again. I go to statistics, time series, I go to graph, then I go to autocorrelation and partial autocorrelation, right? That I select. And here, this cons actually non-stationary data, and it is at level. Now what I do, first difference of cons. So here I write d dot com, right? D dot cons, right? So that means first difference of d cons. Sorry, first difference of cons variable, right? Then I press OK. You can see our data is now d cons. That means first difference of cons variable. Okay, here you can see as before Q statistics and probability, and all probability are, you can see, more than 5%, right? You can see this one 24.62%, this one 6.59%, meaning that more than 5%, meaning that we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that first difference of cons variable is stationary. Okay, now I check about our second variable. I go to statistics, then I go to time series, then I go to graph, then I go to autocorrelation, partial autocorrelation, right? I go there. Okay, our second variable is Ex, right? That I select, right? Ex at level, that I select, then press OK. You can see the correlogram at Ex, right? Here you can see the probability all are 0, meaning that our data is not stationary at meaning that our data is not stationary at level, right? Okay, now I check what happens if the data is in the first difference. As before, I go to statistics, I go to time series, I go to graph, then I go to autocorrelation and partial autocorrelation as before. Okay, here I put just d dot ex. That means these data now become first difference of ex. Okay, then I press OK. So here is the result. You can see the first difference of ex, and as before q statistics and probability, you can see all the p value are more than 5%, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that first difference of ex is stationary. And we have the last variable. We check also time series as before, graphs and autocorrelation, partial autocorrelation I go. Okay, the third variable is GDP, right? GDP at level, I check it, right? It is coming up. You can see the GDP at level. Here you can see Q statistics and P value all are less than 5%, right? Very small, meaning that this variable is not stationary at level. Okay, then as before, I go to statistics, time series, then graph, then autocorrelation and partial autocorrelation, right? I select this one. Okay, then this GDP, I just do it as before, d dot GDP, right? First difference of GDP, then I press OK. So it is coming up dGDP. You see from here the probability are all more than 5%, right? Meaning that first difference of GDP is stationary, right? So actually, so what is our condition? The condition is, I said you last time, just 1 minute, I don't know why I said it. Okay, I just double check. Okay, okay, I'm just write it again. The condition of the Johansen test of cointegration is variables are non-stationary at level, but when I convert them into first difference, right? First difference, then they will become stationary, right? So that is the condition of the Johansen test of cointegration. And here our three variable actually fulfilled all these condition, because our three variables cons, ex and GDP were non-stationary at level, but when we converted them into first difference, then they became stationary. So we can run the Johansen test of cointegration, and that we shall do now. Johansen test of cointegration. I go to statistics to run it, right? I go to statistics, then I go to multivariate time series, then I go to co-integrating rank of a VECM, right? Right, I select this one. Okay, and here I take our three variables cons, ex and GDP, right? And here actually 3 lakhs should be chosen, right? according to the lag selection criteria, 3 lags should be chosen. Okay, here I am putting actually 4 lags because this 4 will become 3, right? This thing will happen. So if I put 4, it will become 3. So I have to put here 4 so that I can get result of 3. And here I also select one thing, reporting. I select also report maximum eigenvalue statistics, that I select here, and I go to model, and here out of many I select this one. There are many trend specification. So here I select constant one, and then I can run the model now, right? We are set, we can proceed. I click OK. So the result is coming up gradually. You can see the result is here. Okay, and here you can see the Johansen test of co-integration, right? So that is the outcomes, Johansen test of co-integration. And here first is the trace statistics, you can see, and this one is the critical value at 5% level. And here is the maximum rank, meaning that there is 0 rank, 1 rank, 2 rank, 3 rank, right? Okay, first I talk about 0. Actually, what is this 0? 0 means actually there is no co-integration among our 3 variables such as cons, EX and GDP, right? Okay, make sure when we run the Johansen test, we used the non-stationary variable. Make sure that means we use these 3 variables at level when we run the Johansen test of co-integration, right? Make sure, right? And here you can see from here also, you see actually we use these 3 variables which are non-stationary, right? But after first differencing of these 3 variables, they will become stationary, but here they are non-stationary. Okay, however, okay, I say what does mean by 0 here? 0 means that is the null hypothesis, that there is no co-integration among our 3 variables such as cons, EX and GDP. So that is the null hypothesis. And here you can see the trace statistics is how much? 35.66, and critical value is how much? 29.68. So here our statistics value is more than critical value, meaning that 35.66 is more than 29.68. And when the statistics is more than critical value, we can reject the null hypothesis all the time. So meaning that we can reject this 0, meaning that we can reject this statement that there is no co-integration among three variables. So meaning that this statement we can reject. Okay, then we come here. So that is our second statement, right? 1, right? Okay, that is the second statement, and that is 1. What is 1 here? 1 means actually there is one co-integration model, right, in this system, right? That is the null hypothesis. That is 1, right? There is one co-integration model in this system. Okay, and here we can see that that this trace statistics is smaller than critical value, right? So meaning that actually what is the guideline? When the statistics is smaller than critical value, then we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that there is one co-integration model in this system, meaning that in other way our three variables such as cons, ex and GDP are co-integrated, meaning that these three variables have long run associationship, or in the long run they move together. And also you can see the star is here. Star means actually there is one co-integration model. So that is why the star is here, right? Star is here. That means we should select one co-integration model in the system. Okay. So that is the trace statistics. Then what about max statistics, right? So actually the story is almost same. So here is the 0, right? What does mean by 0? There is no co-integration among three variables such as cons, ex and GDP. And here the statistics value is 27.15 and critical value is 20.97. And when the statistics is more than critical value, we can reject the null hypothesis. That is always a guideline. Okay, now we come here. 1. What is 1? 1 means there is one co-integration model in this Johansen system. Okay, here you can see the statistics value 7.84 is smaller than critical value, which is 14.07. And when the statistics value is less than critical value, then we cannot reject null hypothesis. Rather, we accept null hypothesis, meaning that this one is true, this one is correct, meaning that there is one co-integration model in this system. So actually it means that our three variables such as cons, ex and GDP are co-integrated, or our three variables have long run associationship, or in the long run they move together. Okay, and what is the guideline? The guideline is when the variables are co-integrated, right, co-integrated, then we can run the var model. Sorry, we can run the VECM model. But if they are not co-integrated, co-integrated, we should run only var model, right? Not VECM. And here our variables are co-integrated, so we can run the vector error correction model. So we shall do it now. We shall run the VECM model now, right? Thank you very much to stay with me for a while.